This is the EdExcel AS Level Further Maths Paper 1 covering the Core Pure module, and this is from the 2022 series. Question number 1. We have the matrix A, the matrix B, and the matrix C, which are given. And we are given that I is the 3x3 identity matrix. Now, at this point, I suggest using your calculator, enter in these matrices. So, if we go to the matrix submenu, let's define matrix A. We have 3 rows, 2 columns. So type in the matrix A, as we see here. Let's now define matrix B. We've got 2 rows and 3 columns. So type in matrix B, as we see here. Let's also define matrix C. We have for matrix C a 3x3 matrix. So type in matrix C, as we see here. Now for the first part of part A, we have to show that there is an integer k for which AB subtract 3c plus k times the identity matrix is equal to the 0 matrix, stating the value of k. So for the first part of part A, what we need to do is work out the matrix AB. And if I work out the matrix AB, I've got the matrix A being multiplied with the matrix B. And if I work out what this is, well, we have matrix A multiplied by matrix B, and the result is what we see here. AB is equal to 963, 1233, 24, minus 1833, and 30. And so, when we come to work out AB subtract 3c plus ki equals 0, we have AB subtract 3 times the matrix C, and then we add on k times the identity matrix. Along the leading diagonal we have k, the rest are zeros, and this will equal the 0 matrix. Now we can actually work out what AB subtract 3c is. AB is what's stored into the matrix answer variable. So we have AB subtract 3 times the matrix C, and if I work that out, it turns out we have 24 times the identity matrix, and the 24 is along the leading diagonal. And then we add to this k times the identity matrix, and the result of this calculation is equal to 0. And if I combine this 3x3 with this 3x3, we end up with 24 plus k times the identity matrix, which is equal to the 0 matrix. And at this point, we can see that 24 plus k is equal to 0, in which case k is equal to negative 24. Next, we have to explain why there can be no constant m such that BA subtract 3c plus mi equals 0. So, for the next part of the question, let's first of all work out what BA is. We've got the matrix B being multiplied by the matrix A, And if I work out what this is, we can use our calculator. We have matrix B times matrix A, and it turns out we get this 2 by 2 matrix 19, 20, 13, 53. So what we see then is that BA is a 2 by 2 matrix. Now 3C is a 3 by 3 matrix, we saw that before, and so it's not possible to find BA subtract 3C, and that's because the matrices are incompatible. We've got a 2 by 2 subtract a 3 by 3, that's impossible to work out, and so therefore there's no constant m which satisfies BA subtract 3C plus mi equals 0. Now for the first part of part B, we have to show how the matrix C can be used to solve the simultaneous equations minus 5x plus 2y plus z equals minus 14, 4x plus 3y plus 8z equals 3, minus 6x plus 11y plus 2z equals 7. So for the first part of part B, our system of equations can be written as this matrix, which are the coefficients of x, y, and z, multiplied by the variables x, y, z, and that's equal to the vector minus 14, 3, 7. And at this point you can recognise here we have the matrix C multiplied by x, y, z, and that's equal to minus 14, 3, 7. And so x, y, z, that's going to equal C inverse multiplied by minus 14, 3, 7. And that's how we find out what x, y, z is. And now, hence use your calculator to solve these equations. So for the next part, to find out what x, y, z is, we first of all need to calculate C inverse. Now, what we will do is first of all define what this vector is. And we will do that using matrix D. We have 3 rows and 1 column. And so now that we've got matrix D, let's calculate the inverse of C. Here is the inverse of the matrix C. And what we are doing is we are multiplying this by minus 14, 3, 7. And so if we were to work out what that is, we've got C inverse, which is stored into our matrix answer, and then we multiply this by the matrix D, and if we do that, we end up with 7 over 2, 3, and minus 5 over 2. And so at this point, we can conclude x is equal to 7 over 2, y is equal to 3, and z is equal to minus 5 over 2. Question number 2. For part A, we have to express the complex number w equals 4 root 3 minus 4i in the form r times by the cosine of theta plus I sine theta, where r is greater than 0 and theta is in between minus pi and pi. So, for part A, we first of all need to find out what r is, and r is equal to the modulus of w, and to work out the modulus of w, we have 4 times by the square root of 3 squared plus minus 4 squared all square rooted. And if I work out the value of this, we have the square root of 4 root 3 squared plus minus 4 squared, and that's equal to 8. We now need to find out what theta is, and theta is equal to the argument of w, and so that's equal to the arc tangent of minus 4 divided by 4 root 3. And if I work out what this is, we have the inverse tangent of minus 4 divided by 4 root 3, and it turns out we get minus 30, which in radians is minus pi over 6. It's equivalent to 30 degrees. And now that we know what r is and we know what theta is, we can therefore conclude that the complex number w is equal to 8 multiplied by the cosine of minus pi over 6 plus I times by the sine of minus pi over 6. Here is what w is. Next, for part B, we have to show on a single Argand diagram the point representing w, and then the locus of points defined by the argument of z plus 10i equals pi over 3. Well, here is an Argand diagram. We've got our real axis and our imaginary axis. Now, if we think about the point representing w, well, w would have coordinates 4 root 3 and minus 4. Now, if I work out what 4 root 3 is, I end up with 6.9 etc. It's close to 7. And so if I plot that point, I have the point w, which is around here. And adding on the coordinates of w, I have 4 root 3 minus 4. And then the locus of points defined by the argument of z plus 10i equals pi over 3. Well, first of all, let's rewrite this as the argument of z minus 10i equals pi over 3. And so it crosses the imaginary axis at minus 10. It will be a half line, and we have the gradient of the line equaling the tangent of pi over 3. Now pi over 3 is 60 degrees, so if we grab our ruler and then measure out 60 degrees, the gradient of this line is the tangent of pi over 3. And so, drawing our half line, like so, you can see then here, we have the argument of z plus 10i equaling pi over 3. So we've got the point W, we've got our half line. Now for part C, hence determine the minimum distance of W from the locus, the argument of z plus 10i equals pi over 3. So what we need to do here is recognize that the minimum distance is over here. We will call this D. And hopefully you recognize we've got a right-angled triangle. And what we can do is form a right-angled triangle such as the one we see here. And we need to calculate this length of D. How could we go about that? Well, if we define the Cartesian equation of the locus of the argument of z plus 10i equals pi over 3, well, if I work out what this is, we have y equals, now the gradient will equal the tangent of pi over 3. Now pi over 3 is 60 degrees, and so the gradient of our line is root 3. So we have y equals root 3 x subtract 10. So the gradient is the tangent of pi over 3, and the y-intercept is minus 10. It's in the form y equals mx plus c. So now that we've got the Cartesian equation of this line, what we can do is find out what this point is. And we can do that by recognizing that this point over here has a y-coordinate of minus 4. And we can find out the x-coordinate and then find out the length of this line here. So when y equals negative 4, we have negative 4 equals x times by the square root of 3 minus 10. Adding 10 to both sides, we end up with 6 equals x times by the square root of 3. And so therefore, x will equal 2 times by the square root of 3. And so if I go back to my diagram, we have 2 times by the square root of 3. And so what we can therefore conclude is this distance will equal, well, we are going from 2 root 3 to 4 root 3, so that distance is 2 times by the square root of 3. And so the horizontal distance from L to W is 2 root 3. Now, if I go back to my diagram, I know that this angle over here is equal to pi over 3, which is the same as this angle over here, which is also pi over 3. And so now what we can do is find out the length of D using trigonometry. Let's redraw this triangle. So with this right-angled triangle, we've got the hypotenuse, we've got the opposite, the minimum distance D, that's equal to 2 root 3 times by the sine of the angle pi over 3, and it turns out the minimum distance is equal to 3. Question number 3. With respect to the right-hand rule, a rotation through theta degrees anticlockwise about the y-axis is represented by this matrix here: cos theta, 0, sin theta, 0, 1, 0, minus sin theta, 0, cos theta. We've got the point P with coordinates 8, 3, 2, and the point Q is the image of P under the transformation reflection in the plane y equals 0. And for part A, we have to write down the coordinates of Q. Well, if we've got a coordinate axis and we reflect in the plane y equals 0, well, this is the same as reflecting in the xz plane, as we see here. So if I've got the point P with coordinates 8, 3, minus 2, if I reflect that in the xz plane, I multiply the y coordinate by minus 1, and so therefore the point Q would have coordinates 8, minus 3, 2. Now the point R is the image of P under the transformation rotation through 120 degrees anticlockwise about the y-axis with respect to the right-hand rule, and what we have to do is determine the exact coordinates of R. Well, our angle over here is 120 degrees, and so what we can do is say that T is equal to cos 120, 0, sin 120, 0, 1, 0, minus sin 120, 0, cos 120, and if I work that out, we end up with this matrix here: minus a half, 0, root 3 over 2, 0, 1, 0, minus root 3 over 2, 0, minus 1 half. And so therefore, we've got our matrix T, we've got our point R, rather we've got our point P with coordinates 8, 3, 2, and if we work out what this is equal to, we've got minus a half times by 8, which is minus 4, plus 0 times by 3, which is 0, and then we've got root 3 over 2 times by 2, which is just root 3. So here we end up with minus 4 plus root 3, and then we've got 0, 3, and then 0, and then we've got minus root 3 over 2 times by 8, plus 0, minus 1. So I end up with minus 4, root 3, minus 1. And so therefore, the coordinates of R we've got minus 4 plus root 3, 3 minus 4 root 3 minus 1. Now, for part C, we have to find the magnitude of PR, giving your answer as a simplified surd. So we've got the point P, 832, and we've got the point R over here. So what we first of all need to do for part C, well, let's just write down the coordinates of P. The coordinates of P, we've got 8, 3, 2, and so therefore the vector PR, I am starting at P, I want to end up at R, so to go from 8 to minus 4 plus root 3, well, from 8 to minus 4, I travel a distance of minus 12, and then I've also got the root 3 with it. So we have root 3 minus 12. Then from 3 to 3, well, that's just 0. And then from 2 to minus 4 root 3 minus 1, well, the minus 4 root 3 isn't going anywhere, but then we've got the 2 going to the minus 1, so that's minus 3. So this is what PR is. And therefore, for us to find the magnitude of PR, if I work out what this is, I've got root 3 minus 12 all squared plus 0 squared plus minus 4 root 3 minus 3 squared, and then it's square rooted, and if I work out what this is, we have the square root of root 3 minus 12 squared plus minus 4 root 3 minus 3 squared. Turns out we get 2 root 51. So we have 2 times by the square root of 51. Now we have to show that PR and PQ are perpendicular. Well, what we need to do first is find out what PQ is. If I write down the coordinates of Q, we've got 8 minus 3, 2. And so therefore, if we were to find out what the vector PQ is, we are going from P to Q. Well, from 8 to 8, we go 0. Rather, let's write this as a column vector. So we've got PQ equaling 0, and then to go from 3 to minus 3, that's minus 6. And then from 2 to 2, that's 0. And now that we know what PQ is, we can do PR dot with PQ. And so, therefore, PR dot with PQ well, we've got PR, which is this vector over here. And then we dot this with PQ. And it turns out we have 0 plus another 0 plus 0, which is equal to 0. And so therefore, the vectors are perpendicular. Now for part E of the question, hence determine the exact area of the triangle PQR, giving an answer as is said in simplified form. Well, here we've got the triangle PQR. We know that the distance PQ is, rather the distance PR is 2 times the square root of 51. So we've got the distance PR being 2 times the square root of 51. We can also determine the distance of PQ. The distance of PQ, well, if I know that PQ is equal to 0 minus 6, 0, then the magnitude of PQ will equal 0 squared plus minus 6 squared plus 0 squared, and then square rooted, which is equal to 6. So this distance is 6. We've got the height of the triangle, the base of the triangle, and so therefore the area is equal to 1/2 times by the base times by the perpendicular height, 2 times the square root of 51, and it turns out we get 6 times by the square root of 51 units squared. Question number 4. The roots of the quartic equation 3x to the 4 plus 5x cubed minus 7x plus 6 equals 0 are alpha, beta, gamma and delta. And before we do anything else, we can rewrite this equation as x to the 4 plus 5 over 3 x cubed plus 0x squared minus 7 over 3x plus 2 equals 0. And from this, we can see that alpha plus beta plus gamma plus delta is equal to negative 5 over 3. Alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus delta gamma is equal to 0. Then we have alpha beta gamma plus alpha beta delta plus alpha delta gamma plus beta delta gamma. That's equal to negative minus 7 over 3, which is 7 over 3. And then alpha beta gamma delta, that will equal 2. And with all this, we have to make our method clear and, without solving the equation, determine the exact value of the following. For the first part, we've got alpha squared plus beta squared plus gamma squared plus delta squared. So the way we approach this is to think about alpha plus beta plus gamma plus delta all squared. And the result of this expansion is shown here. We've got alpha squared plus 2 alpha beta plus 2 alpha gamma plus 2 alpha delta plus beta squared plus 2 beta gamma plus 2 beta delta plus gamma squared plus 2 alpha delta plus delta squared. And at this point, we can rearrange. We end up with alpha squared plus beta squared plus gamma squared plus delta squared equals alpha plus beta plus gamma plus delta all squared. Subtract two lots of alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus delta gamma. And we know what each of these results are. So we have minus 5 over 3 and all of this is squared, and then we subtract two lots of 0. And it turns out when we do that, we get 25 over 9. So here we have minus 5 over 3 all squared. For the next part, we've got 2 over alpha plus 2 over beta plus 2 over gamma plus 2 over delta. Well, we'd have two lots of alpha beta gamma plus alpha beta delta plus alpha delta gamma plus beta gamma delta divided by alpha beta gamma delta. So if I work this out, I have 2 multiplied by, well, I have 7 over 3, and then this is divided by 2. So it turns out here we get a value of 7 over 3. And now we have 3 minus alpha times 3 minus beta times 3 minus gamma times 3 minus delta. So far I've got 3 minus alpha times 3 minus beta times 3 minus gamma times 3 minus delta. And what this is the same as is multiplying. Well, if I times this bracket with this bracket, I've got 9 minus 3 alpha minus 3 beta plus alpha beta. And then timesing these two brackets, I've got 9 minus 3 delta minus 3 gamma plus gamma delta. And now to multiply these together, we can use the grid method. So I've set up my grid, and if I use the grid method, 9 times 9 is 81. Here I have minus 27 delta, and then I have minus 27 gamma, 9 gamma delta, minus 27 alpha, then I have 9 alpha delta, 9 alpha gamma, minus 3 alpha beta gamma, minus 27 beta, 9 beta gamma, rather 9 beta delta, 9 beta gamma, minus 3 beta gamma delta, 9 alpha beta, minus 3 alpha beta delta, minus 3 alpha beta gamma, and alpha beta gamma delta. So what can we conclude from this? Well, we can conclude I've got 3 minus alpha 3 minus beta (3 minus gamma) 3 minus delta, that will equal, well, I've got 81, and then I subtract 27 lots of alpha plus beta plus gamma plus delta, and then I add 9 lots of alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma alpha, and then I subtract 3 lots of alpha beta gamma plus alpha beta delta plus alpha gamma delta plus beta gamma delta, and then I have alpha beta gamma delta. So if I work all of this out, I have 81 subtract 27 multiplied by minus 5 over 3, and then I add on 9 multiplied by 0, and then I subtract 3 times by 7 over 3, and then I add on the value of 2, and if I work out what all of this is, I get 121. Question number 5. For part A, we have to use the standard summation formulae to show that for n being a natural number, the sum from r equals 1 to r equals n of 3r squared minus 17r minus 25 equals n times n squared minus an minus b, where a and b are integers to be determined. So for part A, we have the sum from r equals 1 to r equals n of 3r squared minus 17r plus 25, and if I work out what that is, well, I can split that up as the following. We have 3 times the sum from r equals 1 to r equals n of r squared, subtract 17 times the sum from r equals 1 to r equals n of r, plus 25 times the sum from r equals 1 to r equals n of 1. So I have 3 times by, now the sum of r squared, if we go to the formula book, that is given here, and the sum of r cubed is given over here. We're only interested in this one. So we have 3 times by 1/6 n times n plus 1 times 2n plus 1. Then we subtract 17 times by, well, here the sum of r, that's given by 1/2 n times by n plus 1, and then we have minus 25 n. So 3 times a sixth is a half, so I've got a half times by n times by n plus 1 times 2n plus 1, and then I subtract, well, here I've got 17 over 2 times by n times by n plus 1, and then I have minus 25n. And at this point, we can take out an n as a common factor, and then inside the bracket, I've got 1/2 times by n times by, rather, 1/2 times by n plus 1 times 2n plus 1, subtract 17/2 times n plus 1, and then I subtract 25. Now, if I expand the brackets, well, I still have n, and then here I've got 1/2, and then inside the bracket I have 2n squared plus 3n plus 1, subtract 17/2n, subtract 17/2, and then subtract 25. And then if I multiply the half into this bracket, I have n multiplied by n squared plus 3/2n plus 1 half, and then the rest of it stays the same. We then subtract 17/2n, subtract 17/2, and then 25. And what I end up with, I have n times by n squared, subtract 17n, subtract 33 as my final answer. In other words, a is equal to 17, b is equal to 33. Now for part B, we have to explain why, for k belonging to a set of natural numbers, the sum from r equals 1 to 3k of r times the tangent of 60r degrees is equal to minus k root 3. So, for part B, we have the sum from r equals 1 to r equals 3k of r times by the tangent of 60r degrees. Well, this is the same as multiplying k by the sum from r equals 1 to r equals 3 of r times by the tangent of 60r degrees. So, we have k times by 1 tan 60 plus 2 tan, well, here I'd have 120, and then I'd have 3 times by tan 180. 3 times 60 is 180. So, we end up with k times by root 3 minus 2 root 3 plus 0, which is equal to minus k root 3. But what we have to do is justify what happens when r equals 4, 5, and 6, etc. So, noting that the tangent function repeats every 180 degrees, what we can therefore say is the sum from r equals 3m plus 1 to r equals 3m plus 3, in other words, 4th, 5th, and 6th term of r times by tan of 60r degrees, well, that will equal 3m plus 1, and then the fourth one will be the same as tan 60, which is tan 240, and that's going to equal root 3, because if I add on 180 degrees to 60 degrees, I'd still get root 3. And then for the next one, I would have 3m plus 2 times negative root 3, because for the next term, we have tan of 120 is minus root 3. And then for the next one, I have 3m plus 3 times by 0. So let's just make a note over here. This is the 60 degrees plus the 180. Well, this is rather, if we're more specific, this over here is the same as the tangent of 60 plus the 180. What this is the same as is the tangent of 120 plus the 180, and what this is the same as the tangent of 0 plus the, rather, this is the tangent of the 180 plus another 180. So we've got the 60 degrees, we've got the 120 degrees, and we've got the 180 degrees, but we are repeating that every 180, which is why we get the same results. And so because of that, this result here is equal to minus k root 3. So what we are essentially talking about over here is the situation for r equals 4, 5, and 6, and then also the r equaling 10, 11, and 12, and then r equaling 16, 17, 18, and so on. So that's what this is referring to. The m is just referring to each sort of batch of numbers from 0 to, from r equals 1 to r equals 6, because that batch is being repeated. And so because of that, what we can therefore conclude is the sum from r equals 1 to r equals 3k of r times by the tangent of 60r degrees, that will equal minus k times by the square root of 3. Now for part C, using the results from part A and part B and showing all your working, we have to determine any value of n that satisfies the following equation. We've got the sum from r equals 5 to n of 3r squared minus 17r minus 25 equaling 15 times the sum from r equals 6 to r equals 3n of r times the tangent of 60r degrees squared. Now, first of all, let's consider the left-hand side. If I consider the left-hand side, I've got this sum, and because we've got the sum from r equals 5 to r equals n, I need to rewrite this as the sum from r equals 1 to r equals n, subtract the first 4 terms. And so what we will end up with over here is n times by n squared minus 7n minus 33, and then because we've got the sum from r equals 1 to r equals 4, that will equal 4 times by 3 times by 4 squared minus 17 times 4, subtract 25. So what we have then is n times n squared minus 7n minus 33, and then we add on 180. Now let's consider the other side. So here we've got 15 times by the sum from r equals 6 to 3n of r times tan of 60r degrees. Now I'm just going to consider the bit that's inside the bracket, and if I do that, that sum, well, I'm going from r equals 6 to r equals 3n, and that's the same as summing from r equals 1 to 3n, subtract the first 5. Now, I already know what the sum from r equals 1 to 3n is. Well, from r equals 1 to 3k, that's minus k times square root of 3. We replace the n. We replace the k with n. And so what we will have over here then is minus n times the square root of 3. And then we subtract the first 5. So I've got 1 tan 60 degrees plus 2 times the tan of 120 degrees. Then I have 3 times the tan of 180 degrees. 4 times the tan of 240 degrees. And 5 times by the tan of 300 degrees. So if I work out what this is, I've got minus n times the square root of 3, and I've got 1 tan 60, 2 tan 120, 3 tan 180, 4 tan 240, 5 tan of 300, I get minus 2 root 3. So I've got minus n root 3 subtract minus 2 root 3, which is the same as minus n times the square root of 3 plus 2 times the square root of 3. And so what do we need to do in this question? Well, we need to solve this equation here. Now, the result on the left-hand side, we found that to be n times by n squared minus 7n minus 33 plus 180. So this result here is what this is over here. And then we set this equal to 15 multiplied by minus n root 3 plus 2 root 3 all squared, and this result here is what we've just found over here. So now we need to work all of this out. So we have 15 times by, well, if I expand all this out, I end up with 3n squared minus 12n plus 12. And if I factorize out a 3, I have 15 times by 3 multiplied by n squared minus 4n plus 4. So I have 45 times by n squared minus 4n plus 4. And if I expand the brackets, I have 45 n squared minus 180 n plus 180, and I know already that this is equal to n times by n squared subtract 17x subtract 33 plus 180. So this result is what we had over here. And hopefully at this point you can recognize the 180s cancel on both sides. So I have n times by n squared minus 7n minus 33 equals 45 n squared minus 180n. Expand the brackets, so I have n cubed minus 7n squared minus 33n, and then we have on the right hand side 45n squared minus 180n. So if I take everything over to one side, I have n cubed minus 52n squared plus 147n, that's equal to 0. And then I have n times by n squared minus 52n plus 147, and that's equal to 0. And if I factorize this, I have n times by n minus 49 times by n minus 3 equals 0. N is either equal to 0, 49 or 3. And if I go back to the problem we're actually solving, well, R definitely has to be bigger than 5 for this sum to work. And so what we can conclude from here is, as n must be greater than 5, n equals 49 is the only solution. Question number 6. The surface of a horizontal tennis court is modelled as part of a horizontal plane with the origin on the ground at the centre of the court, and I and j are unit vectors directed across the width and length of the court respectively. K is a unit vector directed vertically upwards, and the units are in meters, and after being K, a tennis ball modelled as a particle moves along the path with this equation. We've got R equals minus 4.1 plus 9 lambda minus 2.3 lambda squared I plus minus 10.25 plus 15 lambda j plus 0.84 plus 0.8 lambda minus lambda squared k. Lambda is a scale parameter, with lambda being greater or equal to 0, and assuming that the tennis ball continues on this path until it hits the ground, we have to find the value of lambda at the point where the ball hits the ground. Well, it hits the ground when the k component is equal to 0, so if I go back, I have to set this k component equal to 0. So I've got 0.84 plus 0.8 lambda minus lambda squared equals 0. So if I attempt to solve that, we can use our calculator to help us solve it. It turns out we get lambda equals 7/5 and minus 3/5. And so therefore, what we can conclude is lambda equals 7/5 only. And that's because lambda is greater or equal to 0. Now, the direction in which the tennis ball is moving at a general point on its path is given by 9 minus 4.6 lambda I plus 15j plus 0.8 minus 2k lambda. And we have to write down the direction in which the tennis ball is moving as it hits the ground. Well, we've found the value of lambda for which the ball hits the ground, and all we have to do is substitute that value of lambda in. So, for part B, when lambda equals 7/5, the direction will be given by 9 minus 4.6 times 7/5 I plus 15j plus 0.8 minus 2 times by 7/5 k. And what this is equal to is 2.56 I plus 15j minus 2k. Now, for part C of the question, we have to find the acute angle at which the tennis ball hits the ground, giving your answer in degrees to 1 decimal place. We've got the calculation here to help us find out what theta is. We've got the dot product between those vectors divided by magnitude of this vector times the magnitude of this vector. And if I work out what this is, we've got, well, because it's the absolute value, I've got 2 over the square root of 2.56 0.56 squared plus 15 squared plus 2 squared. We get 0.130, etc. And so therefore theta is equal to the inverse cosine of this, which is 82.51, etc. And so therefore the value of alpha is equal to 90 minus this, which is 7.5 degrees, given to 1 decimal place. For part D of the question, the net of the tennis court lies in the plane r dot with j equals 0, and what we have to do is find the position of the tennis ball at the point where it is in the same plane as the net. Well, we have r, and what we need to do is dot this with j, and the result of this is equal to 0. So for part D, we've got r dot with j equals 0. So we've got minus 4.1 plus 9 lambda minus 2.3 lambda squared. Then we've got minus 10.25 plus 15 lambda. And then we have 0.84 plus 0.8 lambda minus lambda squared. And this is being dotted with j. Well, that's 0, 1, 0. The result of this is equal to 0. And so the I and k components will give 0. And for the j component, we've got minus 10.25 plus 15 lambda dot with 1 equals 0. And so therefore, if I solve for lambda, it turns out lambda is equal to 41 over 60. And knowing that lambda is equal to 41 over 60, we can now find out what r is. And so therefore, r is equal to, well, we have minus 4.1 plus 9 times by 41 over 60 minus 2.3 times 41 over 60 squared. Then we've got minus 10.25 plus 15 times 41 over 60. And then we have 0.84 plus 0.8 times 41 over 60 minus 41 over 60 squared. And if I work this out, 4.1 plus 9 times by 41 over 60 minus 2.3 times by 41 over 60 squared. We get 0.976. Now this value of lambda equaling 41 over 60 gave the j component to be 0. So here we get 0. And then 0.84 plus 0.8 times 41 over 60 minus 41 over 60 squared, we get 0.919. And so this is the position vector. And then for part E, the maximum height above the cut of the top of the net is 0.9 meters. Modeling the top of the net as a horizontal straight line, we have to state whether the tennis ball will pass over the net according to the model, giving a reason for your answer. Well, for part E, as this 0.919, which is the k component, so it's vertically upwards, because this is greater than the 0.9, and this 0.9 comes from here, what we can therefore conclude is the ball is above the net. Now for part F, with reference to the model, we have to decide whether the tennis ball will actually pass over the net, giving a reason for your answer. Well, the ball is modelled as a particle, and this means that air resistance has been ignored, and in reality this would mean that the ball would be lower than what we found in the model, and since it's a 0.92, in other words, this 0.919, just rounded it, is only just greater than the 0.9, it is likely that it will be lower than the top of the net. Question number 7. We want to prove by mathematical induction that for n belonging to a set of natural numbers, minus 5n minus 4, 7 to the n equals 1 minus 6n, 9n, minus 4n, and 1 plus 6n. Now, we want to ultimately replace n with k plus 1. So, we want to somehow show that 1 minus 6 times k plus 1, minus 4 times k plus 1, and 9 times k plus 1, and 1 plus 6 times k plus 1 is what we end up with. Now, the way we start mathematical induction is to consider what happens when n equals 1. And when n equals 1, the left-hand side, we've got minus 5, 9, minus 4, 7 to the power of 1, which is equal to minus 5, 9, minus 4, 7. And then on the right-hand side, we end up with 1 minus 6 times by 1, minus 4 times 1, 1 plus 6 times 1, and 9 times 1. And if I work this out, I get the same result, minus 5, 9, minus 4, 7. And what we see over here is, because the left-hand side is equal to the right-hand side, the result is true for n equals 1. Our next step is to assume that the result is true for n equals k. In other words, when we assume that it's true for n equals k, we've got minus 5, 9, minus 4, 7 to the power of k equaling 1 minus 6k minus 4k, 9k, and 1 plus 6k. And now our next step is to see what happens when n equals k plus 1. So now we will try for n equals k plus 1. We will replace the n with k plus 1, and ultimately we want to show this step over here. So if I try for n equals k plus 1, we've got minus 5, 9, minus 4, 7 to the power of k plus 1, and that's equal to minus 5, 9, minus 4, 7 to the power of k times by minus 5, 9, minus 4, 7 to the power of 1. It's just using the laws of indices. And now if we use our assumption step, we've got this result, which is what we found here. And then we have this matrix being multiplied by the matrix here. And so if we use matrix multiplication, we've got this times by minus 5, so I've got minus 5 times by 1 minus 6k, and then I've got as well the 9k times by minus 4. And then we've got 9 times by 1 minus 6k plus 7 times by 9k. And then we've got the minus 5 times minus 4k. And then we've got the minus 4 times by the 1 plus 6k. And then we've got 9 times by minus 4k plus 7 times by 1 plus 6k. So now if I expand all of this out, well, I've got minus 5 plus 30k minus 36k, and then here I've got 9 minus 54k plus 63k, and then here I've got 20k minus 4 minus 24k, and then here I've got minus 36k plus 7 plus 42k. And if I multiply this out, I've got minus 5 minus 6k minus 4 minus 4k, 9 plus 9k, and I've also got 7 plus 6k. And is this result the same as what I wanted to show here? Well, yes it is. And you can check that out with the multiplications of, you can expand the brackets to double check that. So here this is the same as 1 minus 6 times by k plus 1, because here I end up with minus 5 minus 6k. And then here I can factorize out a 9, leaving me with k plus 1. And here I can factorize out a minus 4, and then I've got k plus 1. And here I've got 1 plus 6 times by k plus 1. And that's exactly what I wanted to show. And so for our conclusion step, as it's true for n equals k, where k belongs to a set of positive integers, it's true for n equals k plus 1, and as it's true for n equals 1, it's true for all positive integers n. Question number 8, we've got figure 1, which shows a sketch of a 16 centimeter tall vase which has a flat circular base with diameter 8 centimeters and a circular opening of diameter 8 centimeters at the top. So here's the top and here's the bottom. A student measures the circular cross-section halfway up the vase to be 8 centimeters in diameter, and the student models the shape of the vase by rotating a curve shown in figure 2 through 360 degrees about the x-axis. And for part A we have to state the value of A that should be used when setting up the model. Well, essentially this axis over here corresponds to the midpoint, and therefore this bit over here will be half of the 8, which is 4. And so therefore for part A we have A equals 4. And if that's the case, then for model, well, let's have a read of the question. It says here 2 possible equations are suggested for the curve in the model. We've got model A, which is y equals a minus 2 times the sine of 45x over 2 degrees. And using A equals 4, I've got y equals 4 minus 2 times the sine of 45x over 2. Degrees. And I've got model B, y equals a, which is 4, plus x times by x minus 8 times by x plus 8 over 100. Now, for each model, we have to find the distance from the base at which the widest part of the vase occurs and the diameter of the vase at this widest point. So what's this exactly asking for? Well, it's asking for the distance from the base at where the widest point occurs. Now, the widest point occurs over here. So what we need to do here is find out this diameter. So that's what this part of the question refers to. And it says the distance from the base. Well, the distance from the base is this distance over here. We'll call it lambda for now. So this is the distance from the base. And that's exactly what we need to find. Now, we have to do this for model A and model B separately. Now, this maximum, if I draw the curve out again, this rough sketch, we've got something looking like that. This maximum over here, we need to find out at what x value does this maximum occur. And the way we can think about this is to think about the maximum of this point. Now, it's difficult, at least at AS level, to find the maximum of this using differentiation, but the way we can approach this, if I think about model A, then I can think about the minimum of y equals sine x, and then what essentially I'm doing, so if I draw the graph of sine x, like that, I can think about this minimum over here, and then, so this is sine x, and then I can think about, well, if I've got a minus something, and then I'm stretching it, etc., this is y equals minus sine x, and then what's happening is I'm moving the curve upwards by 2 and then stretching it to end up with this curve over here. So we can think about where the minimum of sine x occurs and use that to find out where the maximum of this curve for model A occurs. And so if I do that, well, the minimum of y equals sine x, this will be at x equals minus 90. And so therefore, the maximum of our transform curve well, our transformed curve is y equals 4 minus 2 times by the x of the sine of 45x over 2. This is when essentially the 45x over 2 equals minus 90. And this would imply that x is equal to 4. And so therefore, if I go back to my curve, this distance over here is 4 centimeters. And so if this entire distance over here is 8, the remaining bit is 4. So we have here 4 centimeters from the base. So that's with model A. Now let's consider model B. So if I consider model B, well, so far for model B, I've got y equals 4 plus, now I'm going to multiply x by x squared minus 64, we've got a difference of 2 squares, and that leaves me with x cubed minus 64x, and then I'm going to divide this by 100. And to find out where the maximum occurs, I first of all need to differentiate this. And so if I differentiate this curve, let's find out what dy over dx is. Well, I'll end up with 3x squared minus 64 over 100. And now to find the x value at which this maximum occurs, I need to set dy over dx equal to 0. So using dy over dx equaling 0, I've got 3x squared minus 64 over 100 equals 0. X squared is equal to 64 over 3. X is equal to 8. Well, I've got plus minus 8 over the square root of 3. And so, therefore, we can say that the maximum occurs at x equals negative 8 over the square root of 3. And if I actually work out what that is, negative 8 over the square root of 3, I get minus 4.61. And so what essentially we are saying over here is, this distance over here is equal to 4.61, etc. So we can find out what this is by doing 8 take with this to find out what this is. And therefore, we have 8 subtract 8 over square root 3. And if I work out what this is, it turns out we get 3.38 centimeters from the base. So that's using model B. So now we have to find the diameter of the vase at this widest point. Well, for the diameter, I need to use the x values at which my minimums occur. So if I consider model A, I know that when x is equal to minus 4, I can find out the corresponding y. Now I know x equals minus 4 from here. So the corresponding y value will equal 4 subtract 2 times the sine of 45 times minus 4 divided by 2, which is equal to 6. So this bit would represent the radius. Rather, what we want here is the diameter. So the diameter is this entire length, so we need to multiply by 2 rather. So therefore, the diameter is equal to double the 6, which is 12 centimeters. And now, if I consider the situation for model B, that's when x equals negative 8 root 3 over 3, well, let's just leave it as is, minus 8 over the square root of 3. I can find out the corresponding y value. I have 4 plus, and then in brackets I've got minus 8 over root 3 cubed minus 64 times by minus 8 over root 3, and then this is divided by 100. So if I find out what this is equal to, I've got negative 8 over root 3, so I've got 4 plus, and then here I have this cubed minus 64 times this over 100, so I get 5.97, and so therefore what we can conclude over here is that the diameter is equal to twice this, which is 11.94 centimeters. Now for part C, the widest part of the vase has diameter 12 centimeters and is just over 3 centimeters from the base. And using this information and making your reasoning clear, we have to suggest which model is more appropriate. So model B is more appropriate. Now both models have a diameter of about 12 centimeters, but the distance from the base of 3.38 centimeters for model B fits better with the widest part being just over 3 centimeters from the base than 4 centimeters of model A. Now for part D, we have to use algebraic integration to find the volume for the vase predicted by model B. You must make your method clear. So for part D, the volume V, that's going to equal, if I rotate by 360 degrees, I've got pi times by the integral from minus 8 to 8 of 4 plus x cubed minus 64x over 100 squared dx. So if I rewrite this, I've got pi times by the integral from minus 8 to 8, and then here I've got 400 plus x cubed minus 64x over 100 squared dx. And if I take out a 100 squared as a factor, I've got pi, well 100 squared, that's the same as 10,000, so I've got pi over 10,000 times integral from minus 8 to 8, and here I have 400 plus x cubed minus 64x squared dx. So if I work out what this is, I've got pi over 10,000, and if I expand 400 plus x cubed minus 64 all squared, well, what I'd end up with is 160,000 plus x to the 6 minus 800 x cubed minus 512,000x minus 128x to the 4 plus 4096 x squared. So if I work this out, well, what this is the same as is 2 pi divided by 10,000 from the integral from 0 to 8, and then this bit is the same. So if I work out what this is, well, I still have the 200 over 10,000 pi, and then if I integrate, I have 160,000 x plus x to the 7 over 7, and then here I have x to the 4 and then divide by the new power, so I have minus 200 x to the 4, and then here add 1 to the power, divide by the new power. We end up with minus 256,000 x squared, and then here we have minus 128 x to the 5 over 5, and then here 4096 divided by 3 x cubed. And then we are doing this from 0 to 8. And if I work out this entire result, well, the upper limit will just be 8, rather. Work this out of 160 times this plus this to the 7 over 7 minus 200, this to the 4 minus 256,000 x squared, and we have minus 128 over 5 x to the 5 plus 4096 x cubed over 3. So it turns out I get this, and then if I times this by 2 pi over 10,000, so the integral, just double checking that on the calculator, we have 904.64 etc. centimeters cubed, which is approximately 905 centimeters cubed. And now for part E, the student pours water from a full 1 litre jug into the vase and finds that there is 100 millilitres left in the jug when the vase is full. We have to comment on the suitability of model B in light of this information. So for part E, 1 litre is 1000 millilitres cubed, and using the model we'd expect there to be 95 centimeters cubed left, because we've got the 1000 take away the 905, which gives 95 centimeters cubed, which is 95 millilitres. Now there's 100 millilitres left, which is close to this 95 centimeters cubed, and so therefore we can see that model B is appropriate.